right, let's look at your worked out solutions for your second semester exam review. All right, so for number one, it says, what's the one consistent reference point and intercept used for graphing logarithmic functions? And here's our parent function for a logarithm. So remember with a logarithm, it has an x-intercept at 1, 0, and it has an asymptote at x is equal to 0. So here I asked you for the intercept. I could have also asked you for the asymptote. So you can see on the second one, it's switched, right? So for the exponential function, I asked you to give the asymptote, but I also could have asked you to give the intercept. So the intercept for this one is 0, 1, and the asymptote is y is equal to 0. So remember we said that we can change x's to y's, or we can ask additional facts. So we want to be sure that we think about not just the question that's asked, but other variations that could be asked of that same question. Okay, so look at the next one. So for number 3, it says if you have 2 to the x, what change would it make if you put a negative out in front of the entire function? Well, a negative out in front of the entire function is a reflection in the x-axis. So just to try to help you remember all the different transformations we talked about, I listed them all here. So a negative in front of the function, as we said, is reflection in the x-axis. If you have a number in front of your function, then that's going to cause a vertical stretch or shrink. So if this is a number larger than 1, that's going to be a vertical stretch. And if it's a value between 0 and 1, that's going to be a vertical shrink. So that would be like if there's a 2 here, it makes it go twice as high and twice as low. If there's a 1/2 here, it makes it go half as high and half as low. All right, then any value subtracted from x is a horizontal shift. So if you're saying subtracted from, you also can think of the opposite of. So it's going to be the opposite of whatever this number is right here is your horizontal shift. And then any value subtracted from y is your vertical shift. So this value is not stuck to the x. It could be moved to the other side and grouped with the y. So that means it's going to be a vertical shift. If I subtract it over to the other side, that'd be y minus k. So that means that k would be my vertical shift. If I don't want to move it over there, if I want to leave it here, then I don't do the opposite of it. I use that value exactly as it is. So for instance, if I have a parent function of log base 3 of x, and we want to talk about what transformations have been made to this equation, then what's being subtracted from x, the opposite of this value would be a positive 4. So that's a horizontal shift of a positive 4, which means it goes to the right. And then this plus 5 is a vertical shift of a positive 5. So vertical being positive means that it's going to go up. All right, then for number 5, we've got the log base 2 of 1/4. So remember that I can switch this from its log form to its exponential form. So that's going to be, I don't know what the answer is, but it's going to be 2 to the unknown answer is equal to 1/4. So 2 to the unknown answer is equal to 1/4. So now I want to try and get my bases the same so I can set my exponents equal to each other. So I can rewrite 2 as 4 as 2 squared, and then to get it out of the denominator, I'm going to use a negative exponent. And so y would be -2. Now, remember that you do have your graphing calculator for the exam, so you also can type your logs into your graphing calculator. So just a reminder of how you put that in your calculator. You're going to do alpha window, and then you're going to choose option number 5. And that puts that blank on your screen that then you can fill in any base and any value. So for us, we had the log base 2. And then over here, this was 1/4. And that'll give me that same answer. All right, for number 6 and number 7, you could put those in your calculator, but it's so much faster to do by hand because remember that the ln is the same thing as log base e. And when you have a log and an exponential with the same base, because they're inverses of each other, they cancel each other out. So literally ln e drops out, and that just gives us 8. If you rewrote ln as log base e and you switched it to its exponential form and then you got your bases the same so your exponents would be equal to each other, you can see that would also give you x equals 8. So we can use that property to do this one fast and easy. Same thing here, as we said, because exponentials and logarithmics are inverses. If you have an exponential raised to a log where the bases are the same, so they're both 9 here, then those are going to cancel each other out as well. So our answer would just be whatever this x value is here. So in this case, our answer would be 4. All right, so for the next one, remember that when you have two logs that are being subtracted, you can combine them into one log that is being divided. So we can say log base 2 of 16 divided by 4. That would be the log base 2 of 4. So we're saying 2 to the what equals 4. So 2 to the second is equal to 4. Now, if you didn't happen to remember to condense these with that division rule, if you had worked those out as two separate logs, here's the log base 2 of 16, that would be 4. And then here's the log base 2 of 4, that would be 2. So you would have gotten 4 minus 2, which is also 2. All right, then for the next one, they ask us to do ln 5 on our calculator. So remember that, let me scooch this a little bit. Remember that here's your ln button. So we're just going to do ln 5, and then we'll round to however many decimal places that they ask us to. All right, so then for number 10, they ask us to solve the equation ln x squared is equal to 4. So again, ln is the same thing as log base e. So let's switch this from its logarithmic form to its exponential form. So that would be e to the 4 is equal to x squared. All right, now I want to get x by itself, so I'm going to take the square root of both sides. So don't forget when you take the square root that you need to put in a plus or minus. So the square root of e to the 4th would be e squared. So just like the square root of x to the 4th would be x squared. And so we're going to get a positive and a negative e squared. All right, and then when I take those and I plug them back in to make sure they're not extraneous roots, if I take e squared and plug it back in, e squared squared is e to the 4th. So ln e would cancel out and I would get 4. And then if I take negative e squared, so negative e squared squared is also a positive e to the 4th. And then ln e cancels out, just giving me 4. So both of those would be solutions. They both work. All right, then for number 11, they say when you're solving by graphing, if you get overlapping lines, your solutions to the system would be what? So because again, I could change this up, and instead of asking you for overlapping lines, I could ask you something else. Then I went ahead and identified every one of these. So if you have intersecting lines, you're going to get the point of intersection. So that would be, whatever your x and y value are. If you get parallel lines, that means you have no solution, because remember, solution equals intersection. So if they're parallel lines, they never intersect. So that means there's no solution. And that would look like, when you're solving, that would look like something like 16 equals 6, something that's not a true statement, 5 equals 0 or whatever. All right, and then infinitely many solutions is when you get an identity. 16 equals 16, 5 equals 5, 0 equals 0. And if there are infinitely many solutions, then that means there have to be infinitely many intersections. That means I have overlapping lines. So then again, as we were just saying, if you get 16 equals 6, that means no solution. If you get 16 equals 16, that means infinitely many solutions. If you get 5, 3, then that means one solution. So different, again, explaining each of these possibilities for how it might be changed up. Okay, then for number 13, it says using any method, the solution to the system would be what? So we have lots of different choices here. Because this was set up for substitution, that's what I chose to do. So for substitution, remember you solve one of the equations for one of the unknowns, and then you plug that into the other equation in the place of that unknown. So that's what I did. I put x plus 3 in the place of y. And so x minus 4x would be negative 3x. And then I'm trying to get x by itself. So I'm going to take this 3 that I have and subtract it from both sides. So now that's going to give me, let me scooch this a little bit so you can see it. So then that's going to give me negative 3x is equal to negative 6. Divide both sides by negative 3 and we'll get x is equal to 2. So once we find our x value, then you can plug it back into either one of these equations to find the y value. So I use the second one down here. All right, so y is equal to x plus 3, and we just figured out that x was 2. And so we can say 2 plus 3 is equal to 5. So my solution would be 2, 5. Now, the other thing you could do is you could plug values in to see what works in both of those equations. You just have to be careful because there can be more than one solution. There can be infinitely many. All right, looking at number 14. Number 14 says use any method to solve the system. So last time I used substitution, so this time I'll use elimination. So for elimination, you want to get your x's and y's on one side and your numbers on the other so everything lines up. So I just subtracted this 3x over to the left-hand side. So here's my first equation, and then here's my second equation with that 3x subtracted over. Now, I need my coefficients to be opposites of each other for them to cancel out. And so I'm going to multiply this second equation by negative 1. So now I've got negative y plus 3x is equal to 5. So now when I start combining, y and negative y drop each other out. Negative 3 and positive 3x drop each other out. And then 2 and 5 is 7. So I end up with 0 equals 7. So that is not a true statement. So that means that there is no solution to that system. Those would have been parallel lines. All right, then for number 15, they ask us to solve the system of 3 equations in 3 variables. So a couple of things that we can do. We could come down here and we could plug in the solutions into the system until we found one ordered triple that worked in all 3 of those solutions. Okay, so for instance, if I take 2, negative 1, 1, and I plug it in here, I'm going to get 2 plus negative 1 plus 1. So 2 plus negative 1 plus 1 is supposed to equal 2. So let's check that. 2 minus 1 is 1, plus 1 is 2. So yes, 2 equals 2. That one worked. All right, so it has to work not just in one equation, but in all 3 equations. So let's take 2, negative 1, 1 and plug it into the second equation right here. All right, so that's what we did, plugged in 2, negative 1, 1. So that's going to give us negative 4 minus 2 minus 3, which is negative 9, and that's what it was supposed to equal. So it also worked in the second equation. All right, then for our third equation, we're going to put 2 in for x and negative 1 in for y. There is no z, so I don't plug 1 in for anything. So it's just going to be 3 times 2 minus a negative 1 equals 7. So you see that right here. So minus a negative is going to be plus. So 6 plus 1 is going to be 7. So this one ordered triple worked in all 3 of those equations. So that is the solution to the system. Now, another way that we solved the system of 3 equations with 3 unknowns was by using reduced row echelon form on our calculator. So the way that we do that is, first off, we're going to pull out the augmented matrix. So we're just pulling out the coefficients and the constants. So we're going to have 1, 1, 1, 2. Negative 2, positive 2, negative 3, negative 9, 3, negative 1, 0, because there's not a z term there, and then 7. So that's where I got this augmented matrix right here. So here's how we put that augmented matrix in our calculator. So we're going to go to second matrix, go over to edit, and then tell it the order. So we had a 3 by 4, and it'll set that up for you. Then let's just go through and put those numbers in that we just had. So the 1, 1, 1, 2. So 1, enter 1, enter 1, enter 2, enter negative 2. You get the idea. So we'll put all those values in. Then I'm going to quit out of that, and I'm going to go back to matrix. And this time I'm going to go to math, and I'm going to scroll. It's actually faster to scroll up, but I'm going to scroll to reduced row echelon form. And then I'm going to go back to matrix and stay on names, and I'm going to choose the name of wherever I put that. I put mine in A. All All right, and so there is that same solution. 1x equals 2, 1y equals -1, z equals 1. There's my solution to the system.